you probably learned how to factor in Algebra 1, but I find that it's one of the most easily forgotten skills present in high school math students. So, let's take a look at factoring. Now, we've got a quadratic phrase here, and a quadratic phrase has ax squared plus bx plus c. Now, not everything is factorable, but if it can be factored, then factoring may be the easiest way to find the solutions for a quadratic function. So, when I see the phrase x squared minus 7x plus 12, I want to ask myself, what do I put in these two binomials so that if I multiply them out by distributing, I would end up with x squared minus 7x plus 12. So the first term is easy when there's no coefficient in front of the x, and that is just they must be plain x's because x times x is x squared. Now the really important question to ask yourself is, what two numbers add up to be the middle term and multiply to be the last term? So I think they might be 4 and 3, and then I need to look at the signs. See how the 7 is negative and the 12 is positive? That tells me that both numbers that I pick out need to be negative in order for this to work out properly. And we know that it works, let's try another one. Let's try x squared minus 8x minus 20. So I need to pick out what two numbers add up to negative 8 and multiply to be negative 20. So it's possibly easier to think of things that will multiply to be 20 and then think of if there's a combination of way to get those items to equal 8. So maybe I start out thinking 4 and 5. Sure, 4 times 5 is 20, but there's no way to get 4 and 5 to add or subtract to equal 8. So then I think 2 and 10. Well, 2 times 10 is 20, and I know that 10 minus 2 is 8, so I know that 10 and 2 need to be my numbers, and then I just have to decide what needs to be positive and what needs to be negative to get this to work out right. Now let's factor to solve an equation. I have n squared minus 36 equals 5n. Now this doesn't really look like the last thing I factored because my terms are on opposite sides of my equality. So the first thing I need to do is group my terms by subtracting 5n from both sides because factoring is only going to work when things are equal to 0, and you'll see why in just a second. So I set up, this is quadratic, and as I said, it's easy if it's equal to 0. So I set up my two binomials, and I know the first item in each must be an n. So now I've got to think, what two numbers will multiply to be 36 and add up to be negative 5? So I think about that, and it's going to be 4 and 9, with the negative going to the 9 and the 4 having a positive. The only way, as a tip, that you can get two numbers to multiply to be a negative is if one of them is negative and one of them is positive. Now, if n minus 9 equals 0, I would be happy, so I need to set that equal to 0 and see what n would be. And if n plus 4 equals 0, I would also be happy, so I need to set n plus 4 equals to 0 and see what that would be. So if n equaled 9, or n equaled negative 4, I would be happy and my equation would be solved. Now this makes sense so far, because I have a second degree polynomial, and I found two solutions for it, and this makes sense. So when I go to graph them, I know that my zeros, think polynomial unit, are at 9 and negative 4. I have a positive leading coefficient, so when I graph this, it would look like an upward-facing parabola with zeros at negative 4 and 9. Now, you'll always get two solutions, but sometimes they won't both be real solutions. For instance, if you had a polynomial that when you graphed it, it just touched the x-axis, like that, it would only have one solution, and we'll look at those later on in the chapter. And you can also have a parabola that doesn't touch the x-axis at all. It still has two solutions, but they're both going to be imaginary.